Now that we have reviewed all of the algebraic properties, we can use those properties to justify our steps in solving multi-step equations. Before we do that, I want to review solving one-step equations, then two-step equations, and then we'll move on to multi-step equations. The most important part of solving linear equations is knowing the inverse operations. So the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. So all of these you should know by now. The two that I really want to focus on are the inverse operation for a square root and the inverse operation for something to the power of 2 or something squared. So to undo a square root, you are going to square it. So whenever you square a value that has a square root, the square root disappears. And whenever you take the square root of something that's squared, the square disappears. And so these two we will practice with several times to make sure that you remember that the inverse of something squared is the square root, and the inverse of a square root is something squared. But let's go ahead and review one-step equations. So in middle school, and maybe even 6th grade, you started solving equations with one step. And one-step equations, you use inverse operations. So all equations you use inverse operations, but especially when solving one-step equations. So we have x plus 3 equals 7. And I'm trying to get this x by itself. So to get the x by itself, I'm going to subtract 3 from both sides. The reason why I'm subtracting is I have x plus 3. Well, to get rid of that plus 3, I'm going to subtract 3 from both sides. Plus 3 and minus 3 cancel out or zero out, and I'm left with an x on the left, 7 minus 3, which is 4 on the right, and I drop down my equal sign, I get x equals 4. So my final answer would be x equals 4. I can check my answer. So everywhere I had an x, I'm going to substitute a 4. So when I plug 4 in for x, I have 4 plus 3 equals 7. 4 plus 3 is 7 equals 7. I got it right. The next one-step equation has x divided by 5 equals 3. Remember that fractions are division. And to get rid of a fraction, you use multiplication. So use multiplication to get rid of fraction. So to get rid of this fraction, we're going to multiply by the denominator. So when you multiply both sides by 5, so remember, whatever you do to one side, you have to do to the other. Those are your properties of equality. So this would be the multiplication property of equality because I'm multiplying on both sides. When you multiply by your denominator, that cancels out. So I'm left with an x on the left, 3 times 5 is 15 on the right, so my final answer would be x equals 15. When I plug that in, so I got x equals 15, so everywhere I have an x, I'm going to plug in a 15. 15 divided by 5 is 3. 3 equals 3. I got it right. So that's a quick review of one-step equations. You are going to use inverse operations to isolate the variable. Two-step equations are very similar, but rather than just doing one thing, you're going to have to do two. So I am looking at example number 1, and it says 5x minus 3 equals 7. So I'm going to start by drawing a line down my equals sign so that I know whatever I do to the left, I have to do to the right. I'm trying to get this x completely by itself. So first, I need to get 5x by itself. So to get rid of this minus 3, I'm going to add 3 to both sides. So that is the addition property of equality. When I do that, this negative 3 and positive 3 zero out. I'm left with 5x on the left, 7 plus 3 on the right, which is 10. So I still have this 5. Remember, this is 5 times x. 5x is the same thing as 5 times x. To get rid of that multiplication, I am going to divide both sides by 5. That's the division property of equality. When I do that, those 5's cancel out. I'm left with x equals 10 divided by 5. 10 divided by 5 is 2. I can check my answer by plugging in 2 everywhere I had an x. 5 times 2 is 10, minus 3 equals 7. 10 minus 3 is 7. 7 equals 7. I did it right. All right, let's move on to this next one here. So here I have 4 plus x over 2 equals 3. So I have a fraction and I have this 4. I'm going to get rid of this 4 first. So I'm going to draw a line down my equal sign. I'm going to subtract 4 from both sides. So I have a positive 4. To cancel out that positive 4, I'm going to subtract 4 from both sides. 4 minus 4 zeroes out. And I'm left with x over 2 equals 3 minus 4, which is negative 1. To get rid of a fraction, multiply by the denominator. So to eliminate a fraction, multiply by the denominator. We talked about that earlier, but I'm writing it out for you here. So my denominator is 2, so I'm going to multiply both sides by 2. Whatever I do to one side, I have to do to the other. That cancels out that 2, and I'm left with x equals negative 1 times 2, which is negative 2. I could check my work, plug it in here. 4 plus negative 2 divided by 2 is negative 1 equals 3. 4 plus negative 1 equals 3, so 3 equals 3. I know I did it right. On the back side of this page, we go over multi-step equations. So now we might have more than 2 steps. We could have 3, 4, 5, 6, it doesn't matter. Multi-step equations could have as many steps as it takes to get x by itself. So as always, I'm going to start by drawing a line down my equal sign. 18. I can't do anything to that side, so I'm going to keep it 18. Here I see that I have a number outside of my parentheses. Whenever that's the case, I know I could use the distributive property. So 3 times 3x is 9x. 3 times negative 6 is negative 18. So now I have 18 equals 9x minus 18. I'm trying to get this x right here by itself. So the first thing I'm going to do is I'm going to add 18 to both sides. Whatever I do to one side, I do to the other. The reason why I added is I have a minus 18. The opposite of minus 18 is plus 18. So this negative 18 and positive 18 cancel out. I'm left with 9x on the right. 18 plus 18 is 36. My last step, I have 9x. To get rid of that 9, I'm going to divide both sides by 9. I'm going to move up here. So I have 36 divided by 9 equals 9x divided by 9. I just rewrote this right here. When I draw my line here, this 9 cancels out here. 36 divided by 9 is 4 equals x. So my answer will be 4 equals x, or x equals 4. I could substitute that back in to check my work, but I'm not going to do that right now. Rather, I'm going to move on to the next problem. All right, we have 37 equals negative 3 plus 5 times the quantity x plus 6. So I'm going to draw a line down my equal sign to keep my left differentiated from my right. On the left-hand side, I can't do anything, so I'm just going to keep that as a 37. I see here that I could distribute, once again, this 5, so I'm going to just drop down this negative 3. And I'm going to distribute this plus 5, or this positive 5, to everything that follows it. So positive 5 times x is 5x. Positive 5 times 6 is 30. Now on my right hand side, I have some like terms. Remember that constants are like terms, so I have a negative 3 and a 30. So using my calculator, I'm going to add my like terms. Negative 3 plus 30. So negative 3 plus 30 is 27. So now I have 27 plus 5x, so I combine my like terms, equals 37. I'm trying to get this x by itself, so first I need to get this 5x by itself. So I'm going to subtract 27 from both sides. I'm going to move over here. So I get 37 minus 27 is 10 equals, and that zeroed out, 5x is all I have left on the right. My last step, I have 5 times x. Whatever I do to one side, I have to do to the other. So I'm going to divide both sides by 5. That gets rid of this 5 here. 10 divided by 5 is 2. All I have over here is x. So 2 equals x, or x equals 2. The more practice you get with solving equations, the easier it gets. It's all about order of operations and taking your time and making sure you drop down everything. If you drop a negative, you are going to get the answer wrong. That's the most common problem that I see when I'm grading solving linear equations is people forgot their negatives or they use the wrong inverse operation. So take your time when doing that. So I'm going to draw my line down my equal sign. I have negative 8 times the quantity negative 8x minus 6, and then over here on the right I have negative 6x minus 22. So I'm going to distribute this negative 8. I have negative 8 times negative 8x is going to be 64x. Negative 8 times negative 6 is positive 48 equals, I'm trying to see if I can do anything here. I have a negative 6 minus 22. I don't have any like terms. I don't have anything to distribute, so I'm just going to drop it down exactly the same. So first check for like terms, then check to see if you can distribute anything. That makes everything a lot easier. So now I have variables and numbers on the left and variables and numbers on the right. I need to get all my variables to one side, all my numbers to the other. So the variables have to be on one side and the numbers have to be on the other. It does not matter which side is which. That's completely up to you. I'm going to move the variables to the left and the numbers to the right. So I'm going to do the variables first. I need to move this 6x over here. So the inverse operation of minus 6x is positive 6x or plus 6x. Whatever I do to the right, I have to do to the left. So I'm going to add 6x over here also. When I do that, I should have something that cancels out. So that negative 6x and the positive 6x cancel out. 64x plus 6x is 70x. I'm going to drop down the 48 equals, all I have left over here is a negative 22. So now I have all my variables on the left. I need all my numbers on the right. So to get this 48 onto the other side, I have to subtract 48. That zeroes out. So I'm going to move up here. So I have 70x equals negative 22 minus 48. So negative 22 minus 48 is negative 70. So I get negative 70. So all I did is I subtracted negative 22 minus 48. And I got negative 70. I have 70x equals negative 70. So I'm going to divide both sides by 70 to cancel out what's attached to the x. So all I have left is x equals negative 70 divided by positive 70, which gives me negative 1. So for this example, x was equal to negative 1. We have one more example to go through, and then we will do these 4 problems in class as a review before you work on your assigned activity. So this one looks tricky because now I have 2 fractions. And when you have 2 fractions, multiply by the biggest denominator. So multiply biggest denominator. So my biggest denominator here is 10. So I'm going to multiply everything by 10, and that's going to cancel out my fractions. So when I multiply everything by 10, I have to do that to both sides. So whatever you do to one side, you have to do to the other. So I have 10 times x is 10x, and I'm going to leave the 2 the same. Your 10 here cancels out your 10 here, so I'm left with a 3x equals 4 times 10, which is 40. 10x divided by 2 is 5x, so that can be simplified. So I have 5x plus 3x equals 40. I can combine my like terms. 5x plus 3x is 8x equals 40. And you should be thinking right now that your last step is going to be to divide both sides by 8. Almost always, your last step is to divide. If you have a number attached to your variable, so for instance, this 8 is touching this variable, I have to divide by 8 to get rid of it. And that's almost always going to be your last step. So 8 cancels out here. I get x equals 40 divided by 8. You could do that in your calculator, or you would know that that equals 5. So for this last problem, x equals 5. Remember that we multiplied by the biggest denominator, so that biggest denominator canceled out. Then we simplified here. 10 divided by 2 gives you 5x. Combine like terms, 5x plus 3x is 8x, and divided by 8. Next class, we will work on solving equations